A main air compressor on a ship is a vital piece of machinery that produces compressed air used mainly for starting the main and auxiliary engines. Since marine diesel engines are too large to start with electric starters, high-pressure compressed air is required. Key points about main air compressor in ships. Purpose: to supply compressed air, usually 25 to 30 bar, for engine starting, automation, and control systems. Type: normally reciprocating, two-stage, water-cooled compressors are used. Storage: air is stored in air bottles, receivers, after compression. Operation: compresses atmospheric air in multiple stages, low-pressure aero intercooler, aero high-pressure aero, aftercooler aero air bottle. Safety devices: relief valves, bursting discs, temperature sensors, and non-return valves to prevent backflow from the receiver. Maintenance: regular checks on lubrication, cooling water, filters, valve condition, and air leaks. Piping system identification is key to safety, using color codes, labels, and flow arrows to instantly know what's inside every pipe and where it's going. The auxiliary blower in a ship's main engine supplies air at low RPM when the turbocharger is not yet efficient, ensuring smooth combustion, easy starting, and clean operation. The exhaust gas boiler plays a vital role in utilizing engine waste heat to produce steam, but over time, soot deposits build up on its heating surfaces. To maintain efficiency and prevent dangerous soot fires, a soot blowing operation is carried out. High-pressure steam is directed through soot blowers to dislodge carbon deposits and restore proper heat transfer. This process reduces exhaust back pressure, improves fuel efficiency, and keeps the boiler operating safely. Soot blowing is normally done when the engine is under sufficient load, never in port, and always with strict safety precautions. Regular soot blowing ensures cleaner operation, extended boiler life, and safer engine performance. In a two-stroke marine engine, the stuffing box plays a vital role in separating the crankcase from the scavenge space. Located around the piston rod, it uses sealing rings to prevent scavenge air and combustion gases from entering the crankcase, while also stopping lubricating oil from moving upward. This ensures clean separation of systems, reduces oil consumption, and protects engine components from wear and contamination. Regular inspection and maintenance of the stuffing box are essential for efficient and safe engine operation. On board a ship, one of the key responsibilities of the fourth engineer is operating and maintaining the purifier system. The purifier plays a vital role in separating impurities and water from fuel oil and lubricating oil, ensuring that only clean oil is supplied to the main engine and generators. A fourth engineer starts and monitors the purifier during operation, checking for smooth running, correct temperature, and any unusual vibrations or alarms. Regular cleaning of the purifier bowl, discs, and seals is also part of the job, as even small amounts of dirt or sludge can affect performance. When issues arise, such as leaks, overflow, or improper separation, the fourth engineer troubleshoots and carries out necessary adjustments or maintenance. They also assist during overhauls, dismantling and reassembling the purifier under the supervision of senior engineers. By keeping the fuel and lube oil clean, the fourth engineer ensures efficient engine operation, reduces wear and tear, and contributes to the overall safety and reliability of the ship. The purifier's supply pump filters are part of the fuel oil and lube oil treatment system on ships. Function: the purifier's supply pump delivers oil to the purifier at the required pressure and flow. Before entering the purifier, the oil passes through filters that remove dirt, sludge, and solid impurities. This ensures that only relatively clean oil enters the purifier, reducing wear and improving separation efficiency. Key points: 1. Protects the purifier from clogging and damage. 2. Removes solid particles that could affect separation. 3. Ensures smooth operation of the fuel oil and lube oil treatment system. In short, the supply pump filters act as the first line of defense, keeping impurities out before oil enters the purifier. The safety valve is a critical protection device on board ships. It automatically opens when pressure rises above the safe limit, releasing excess steam or air. Once pressure returns to normal, it closes again, preventing dangerous accidents and keeping the system safe. The main engine fuel pump is the heart of a ship's diesel engine. Driven by the camshaft, it pressurizes fuel and delivers it to the injector at the right moment. This ensures proper atomization, efficient combustion, and powerful propulsion to keep the vessel moving across the seas. The oil mist detector is a vital safety device in ship engines. It monitors oil mist inside the crankcase, and if levels rise dangerously, it triggers alarms or engine shutdown to prevent explosions. The first stage of an oil-water separator, OWS, is the gravity separation stage. Here's how it works. Purpose: to remove free oil and large oil droplets from bilge water before finer treatment stages. Process: 1. The mixture of oil and water enters the separator. 2. Due to the difference in density, oil being lighter rises to the top, while water settles below. 3. Coalescing plates or baffles are often used to slow down the flow, allowing oil droplets to join together and separate more easily. 4. The collected oil is directed to a sludge or waste oil tank, while the partially treated water moves to the second stage for finer separation and filtration. In short, the first stage is where the bulk oil removal happens by gravity and coalescence. The oil-water separator, OWS, onboard ships is used to treat bilge water before discharging it overboard, ensuring oil content is below 15 parts per million per MARPOL regulations. Second stage of oil-water separator. The first stage usually uses gravity separation and coalescer plates, allowing oil droplets to rise and separate from water. The second stage is more precise. It uses coalescer filters or fine separation units to remove smaller oil droplets that escape the first stage. This stage ensures the oil content is reduced to within international limits. Sometimes an emulsion breaking process or special filter elements are included in this stage to deal with stable oil-water mixtures. The treated water then passes to the 15 parts per million monitor unit, which checks oil concentration before allowing discharge overboard. In short, the second stage of an OWS is the fine polishing stage, where coalescers or filters capture remaining oil droplets, ensuring water meets the strict discharge standard. A main air compressor on a ship is a vital piece of machinery that produces compressed air used mainly for starting the main and auxiliary engines. Since marine diesel engines are too large to start with electric starters, high-pressure compressed air is required. Key points about main air compressor in ships. Purpose: to supply compressed air, usually 25 to 30 bar, for engine starting, automation, and control systems. Type: normally reciprocating, two-stage, water-cooled compressors are used. Storage: air is stored in air bottles, receivers, after compression. Operation: compresses atmospheric air in multiple stages, low-pressure aero intercooler, aero high-pressure aero, aftercooler aero air bottle. Safety devices: relief valves, bursting discs, temperature sensors, and non-return valves to prevent backflow from the receiver. Maintenance: regular checks on lubrication, cooling water, filters, valve condition, and air leaks. Did you know one small station in a ship can save lives at sea? It's called the lockout station. Here, engineers keep padlocks, tags, and lockout devices to safely isolate machinery during maintenance. By locking switches, valves, and breakers, accidental startups are prevented, ensuring crew safety. Each lock is personal, meaning only the one who placed it can remove it. The lockout station may look simple, but it's a powerful safeguard for every vessel.
Let's talk about how a turbocharger works in a generator and why it matters. A turbocharger is a device that increases an engine's power and efficiency by forcing more air into the combustion chamber. More air means more oxygen, and that allows the engine to burn more fuel, which creates more power. So how does it do that? It starts with exhaust gases from the engine. Instead of just releasing them into the air, the turbocharger uses that hot, fast-moving gas to spin a turbine. That turbine is connected to a compressor wheel on the other side of the turbocharger. As the turbine spins, the compressor pulls in fresh air and compresses it before sending it into the engine. In generators, this matters a lot. A turbocharged generator engine can deliver more kilowatts of electricity from a smaller, more efficient package. It's especially useful in high-demand or high-altitude environments, where engine performance would otherwise drop.
The main engine fuel injector is a key component in marine diesel engines. Its job is to inject the right amount of fuel into the combustion chamber at high pressure, ensuring proper atomization and efficient mixing with air. This leads to smooth combustion, power generation, and reduced fuel consumption. Poor injector performance can cause smoke, knocking, and engine damage. That's why regular testing, cleaning, and maintenance are essential to keep your injector in top condition. An auxiliary boiler in a ship provides steam for heating, cargo handling, and daily services, ensuring safe and efficient vessel operations. The turning gear in a ship slowly rotates the main engine for safe starting, inspection, and maintenance. It prevents damage, spreads lubrication, and ensures the engine is always ready for operation. Purpose of seal log in sewage treatment plant: to ensure no bypass or unauthorized discharge of sewage overboard, to comply with MARPOL Annex 4 and Company SMS procedures, to provide traceability in case of inspections by port state control or class. Typical sealed points in STP-1. Overboard discharge valve from STP. 2. Direct overboard bypass valve, if fitted. 3. Sewage holding tank overboard valve. 4. Any bypass lines that can divert sewage untreated. Only authorized personnel, usually 2E or 4E, verified by chief engineer, can break and reseal STP valves. Every seal number is unique and traceable. Any broken or missing seal must be reported immediately and entered in the log. During PSC or flag inspection, the log is checked against actual seals on the valves. The LT cooler in a ship transfers heat from low-temperature fresh water to seawater, keeping machinery efficiently cooled. The air tank, or air bottle, stores compressed air on board. It supplies air for main engine starting, auxiliary engines, control systems, and service use, ensuring safe and reliable ship operations. The main engine turbocharger uses exhaust gas to drive a turbine, which compresses fresh air into the cylinders. This boosts power, improves combustion, and increases fuel efficiency in ships. The Emergency Escape Breathing Device, or EEBD, provides at least 10 minutes of breathable air, helping crew escape safely from smoke or toxic gas-filled spaces on board. The bunker station is the area on a ship where fuel oil is received from a barge or shore facility. It consists of the bunker manifold, valves, drip trays, and safety equipment. During bunkering, the station is carefully monitored to prevent oil spills, ensure proper sampling, and maintain safe operations as per MARPOL and company procedures. The governor in a generator controls engine speed, keeping frequency stable under varying loads. A sea chest is a vital structure built into the ship's hull, designed to draw seawater for essential operations. It supplies cooling water for the main engine, auxiliary machinery, condensers, and also provides water for ballast and firefighting systems. Fitted with strainers and gratings, the sea chest prevents debris and marine growth from entering the pipelines. Ships usually have both a high and low sea chest to ensure a steady water supply, whether the vessel is in ballast or fully loaded. Proper maintenance keeps this system reliable at sea. The oily water separator removes oil from bilge water, ensuring only clean water is discharged at sea. The Ballast Water Treatment System, or BWTS, is designed to protect our oceans from invasive species carried in ballast tanks. Before discharge, ballast water goes through a two-step process. Filtration removes sediments and larger organisms, while disinfection methods like UV radiation or electrochlorination eliminate harmful microbes. This ensures ships comply with international regulations under the IMO Convention. By treating ballast water properly, vessels prevent ecological damage, safeguard marine biodiversity, and contribute to a cleaner and safer marine environment. The cascade tank in the ship's steam system collects and cools condensate before reuse in the boiler. The main engine lube oil automatic filter removes dirt and metal particles from the oil, It works continuously with an automatic backflushing system to keep the engine well lubricated and protected from damage. In a ship's main engine, the fuel injector plays a vital role in delivering fuel into the combustion chamber at the correct pressure, timing, and spray pattern. Over time, continuous operation causes wear and carbon deposits that affect injection accuracy. That's why fuel injector calibration is essential. During calibration, the injector is tested using a calibration machine to check the opening pressure, spray pattern, and leakage. The pressure is adjusted by adding or removing shims inside the injector spring assembly until the correct opening pressure is achieved. A properly calibrated injector ensures that each cylinder receives the exact amount of fuel, resulting in efficient combustion, lower fuel consumption, and reduced smoke emissions. Regular calibration also helps prevent engine knocking, uneven firing, and damage to pistons or cylinder liners. In short, fuel injector calibration is not just maintenance, it's a key procedure to keep the main engine running smoothly, efficiently, and safely at sea. In a ship's main engine, the fuel injector delivers the right amount of fuel into each cylinder for proper combustion. Over time, injectors can become worn, clogged, or damaged, which can cause poor performance, black smoke, or even engine knocking. To replace a fuel injector, the engine must first be stopped and isolated. The fuel pressure is released, and the high-pressure fuel line is carefully disconnected. Then, the securing bolts are loosened, and the injector is lifted out using the proper tool to avoid damaging the seat. Before fitting the new or overhauled injector, the injector seat must be cleaned properly to prevent any leakage. The new injector is then installed and tightened to the correct torque as per the manufacturer's instructions. After reconnecting the fuel line, the system is bled to remove trapped air. Finally, the engine is started and checked for leaks and proper operation. Regular replacement and maintenance of fuel injectors ensure efficient combustion, reduced smoke, and smooth main engine performance at sea. Replacing the cable wire of a lifeboat is an essential safety maintenance job on board a ship. Over time, the wire can become rusty, worn out, or damaged due to exposure to salt water and weather conditions, which can lead to serious failure during an emergency launch. The process starts by inspecting the old wire for any signs of corrosion, fraying, or broken strands. The lifeboat must be secured safely on the davit cradle before releasing the wire tension. Once it's safe, the old wire is carefully removed from the winch drum and hooks. After that, the new wire rope is installed following the correct reeving pattern and secured properly to avoid twisting or misalignment. The new wire is then greased or lubricated to protect it from corrosion and ensure smooth movement. Finally, a load test and operational test are done to make sure the lifeboat can be safely lowered and hoisted without problems. All details of the replacement must be logged in the maintenance record. Regular replacement of the lifeboat cable wire is vital for crew safety and compliance with SOLAS requirements. The CO2 room on a ship is a secured compartment that stores the fixed carbon dioxide fire extinguishing system. Inside this room are several CO2 cylinders connected to a manifold and pipeline system that leads to areas like the engine room or cargo holds. In case of a fire, CO2 is released to quickly displace oxygen, smothering the flames and stopping combustion. The system can be operated manually or remotely from a safe station to protect the crew from danger. Before activating the CO2 system, ventilation must be stopped, and alarms must sound to warn all personnel to evacuate immediately. Once released, the CO2 gas fills the space, extinguishing the fire without causing damage to equipment. Regular checks of the cylinders, pressure levels, and alarm systems are important to keep the CO2 room ready at all times. This system is vital for ship safety, helping protect the vessel, machinery, and crew from fire emergencies at sea. The lube oil cooler keeps engine oil at the right temperature for smooth and safe operation. The freshwater cooler pump is a vital part of a ship's engine cooling system. It circulates fresh water through the engine and heat exchangers to remove excess heat. The warm water from the engine passes through the cooler, where seawater absorbs the heat before the cooled water returns to the engine. This continuous cycle keeps the main engine running smoothly and prevents overheating during operation. The tail shaft is the final link between the ship's engine and the propeller. It transmits the engine's power through the stern tube, allowing the propeller to rotate and push the ship forward smoothly and efficiently through the water. The steering gear room is one of the most important compartments on a ship, located at the aft or rear part of the vessel. It houses the steering gear machinery responsible for controlling the movement of the ship's rudder. This system allows the vessel to change direction and maintain its course during navigation. Inside the steering gear room, you'll find the hydraulic pumps, rams, control valves, and power units that make up the electro-hydraulic steering system. When the helm on the bridge is turned, signals are sent to the steering gear, which then moves the rudder to the desired angle. The room is also equipped with an emergency steering arrangement, which can be operated manually if there's a failure in the remote control system or power supply. Regular maintenance, oil level checks, and system tests are performed to ensure reliability and quick response. Because steering is vital for safe ship operation, the steering gear room is always kept clean, well-maintained, and ready for immediate use at any time during the voyage. The sewage treatment plant, or STP, is a vital system on board a ship that treats human waste and gray water before it is discharged into the sea. It ensures the vessel complies with MARPOL Annex 4 and helps protect the marine environment from pollution. The process begins when sewage from toilets, washrooms, and the galley is collected in a sewage holding tank. From there, it enters the treatment chamber where biological or chemical processes break down organic matter. Aeration helps bacteria digest waste, converting it into harmless substances. Next, the treated sewage passes through a disinfection unit, where chlorine or ultraviolet light kills any remaining bacteria and pathogens. The clean water can then be safely discharged overboard when the ship is outside restricted areas, while sludge and solids are retained for later disposal. Regular monitoring, maintenance, and sampling are essential to ensure the STP operates efficiently and meets international discharge standards. This system plays a key role in keeping our oceans clean and protecting marine life. Before bunkering begins, it's essential to prepare the SOPEP, or Shipboard Oil Pollution Emergency Plan, to prevent and control oil spills on board. The SOPEP locker is first checked to ensure all materials like absorbent pads, oil booms, buckets, gloves, and containers are complete and ready for use. Drip trays are placed under the bunker connections, and absorbent pads are laid out to catch any fuel that might leak during the operation. Oil booms are also prepared along the ship's side if necessary to contain any spillage from reaching the sea. Empty drums or pails are positioned nearby to collect any waste oil. The responsible officer then checks communication between the bunker station and the engine control room to ensure quick coordination. Before starting, the crew is briefed on their SOPEP duties and emergency actions. All preparations are recorded in the SOPEP checklist. This ensures that if a spill occurs, the crew can respond immediately and protect the marine environment. Secure main engine. After arrival, the main engine is stopped and all systems are secured. Cooling water and lube oil pumps are shut down, indicator cocks opened, and all parameters are properly logged for safety. The generator lube oil filter is one of the most important components in a ship's generator system. Its main purpose is to clean the lubricating oil that circulates inside the engine. During operation, the oil collects impurities such as dirt, carbon, and metal particles that come from engine wear. The lube oil filter traps these contaminants, preventing them from circulating back into the engine parts. Clean oil ensures that bearings, pistons, and other moving components are properly lubricated and protected from damage. If the filter becomes clogged or dirty, oil pressure can drop, leading to poor lubrication and possible engine failure. That's why regular inspection, cleaning, and replacement of the lube oil filter is essential for safe and efficient generator operation on board the ship. Inside the lube oil pump, rotating gears or impellers draw oil from the sump, pressurize it, and deliver it through filters and coolers. This continuous flow ensures smooth lubrication, reduces friction, and prevents overheating of the main engine components. A calorifier in a ship heats fresh water using steam or engine jacket water. It provides hot water for showers, cleaning, and galley use by efficiently transferring heat without mixing the fluids. A thermostatic valve in a ship automatically controls fluid flow based on temperature. It keeps systems like the main engine cooling and lube oil circuits at the right temperature by opening or closing as heat changes, ensuring smooth and efficient engine operation at sea. Bad fuel injection in a ship's engine can cause serious problems. When the injector nozzle is clogged or leaking, the fuel spray becomes uneven, leading to incomplete combustion. You'll notice black or white smoke, engine knocking, and loss of power. Low injection pressure or wrong timing can also raise exhaust temperatures and damage pistons or valves. Proper maintenance, calibration, and regular testing of injectors are essential to keep the engine running smoothly and efficiently at sea. A cylinder honing tool polishes the liner, restoring its smooth, oil-retaining surface. When the main engine stops, the turbocharger's emergency oil system keeps working, supplying vital oil to protect the bearings while the rotor is still spinning. The thermostatic valve automatically controls the temperature of the engine system. When it's cold, it bypasses the cooler to warm up faster, and when it's hot, it directs the flow through the cooler, keeping the engine running safely and efficiently. Before any breakdown happens, make sure your generator's heart is in good shape. Regular crankcase inspection helps you spot wear, leaks, and damage early. Always check the bearings, connecting rods, and crankshaft for smooth operation. Safety first. Never open a hot crankcase. Keep your generator running strong and reliable every voyage. Overheating or overcooling in your generator. One possible reason is a faulty thermostatic valve. The thermostatic valve controls the flow of cooling water and keeps your engine running at the right temperature. Before replacing it, make sure the generator is stopped and fully cooled down. Close the cooling water inlet and outlet valves, then drain the coolant to a safe level. Next, remove the valve housing cover and carefully take out the old thermostatic valve. Inspect the housing, clean it, and check for corrosion or dirt. Then install the new valve in the correct direction, replace gaskets or O-rings if needed, and tighten all bolts evenly. After that, refill the cooling system with fresh coolant, open the valves, and bleed any trapped air. Finally, start the generator and observe the temperature. Make sure there are no leaks and that the cooling system maintains the proper engine temperature. Always remember, a well-functioning thermostatic valve helps your generator run efficiently and prevents costly engine damage. Regular maintenance saves time, fuel, and ensures safe operation at sea. When you see a valve marked 5K-25, it actually tells you two important things. The 5K means the valve can handle up to 5 kilograms per square centimeter, or about 71 psi of pressure. The 25 indicates the size, 25 millimeters, or roughly 1 inch in diameter. So, a 5K to 25 valve is a medium pressure valve commonly used in ship systems like cooling water or lube oil lines. Always check these markings to ensure the right valve for the job. Keeping your main engine's turbocharger clean is essential for efficient engine performance. Over time, soot, carbon, and oil deposits build up on the turbine and compressor sides, reducing airflow, causing high exhaust temperatures, and lowering turbocharger efficiency. That's why we perform turbocharger washing, to keep the system running smoothly and efficiently. There are two main types of washing: dry washing and wet washing. Dry washing is done while the engine is running at normal load, using abrasive materials like crushed nutshells or rice husk to clean the turbine blades. It helps remove dry soot and hard carbon deposits without shutting down the engine. Wet washing, on the other hand, uses fresh water or a cleaning solution sprayed through the air inlet while the engine is running at a reduced load, usually around 50%. This method removes sticky salt and oil residues from both the compressor and turbine sides. Before washing, make sure the drain lines are open and always follow the manufacturer's procedure for water quantity and timing. After washing, slowly bring the engine back to full load while monitoring turbo speed, exhaust temperature, and air pressure. Regular turbocharger washing improves airflow, reduces fuel consumption, and prevents damage from unbalanced deposits. It's a simple maintenance task that ensures your main engine runs efficiently, saving fuel and extending the life of your turbocharger. The tube-type lube oil heater heated by steam plays a key role in keeping the generator ready for operation. Its main job is to warm the lubricating oil before starting, so it maintains the right viscosity for smooth circulation and proper lubrication. In this system, steam from the ship's auxiliary boiler flows through the heater's inner tubes, while the cold lube oil passes around them in the shell. Heat transfers from the steam through the tube walls into the oil, raising its temperature to around 40 to 50 degrees Celsius. The steam then condenses and drains back through the condensate line. By maintaining warm oil, the system ensures quick oil pressure buildup, reduces friction, and prevents wear on bearings and other moving parts. Regular inspection for leaks, cleaning of tubes, and checking steam traps help keep the heater efficient and reliable for every engine start. The steam trap in a generator's lube oil heater plays a vital role in keeping the heating system efficient. As steam heats the lube oil, it condenses into water, called condensate. The steam trap automatically removes this condensate and air from the system without letting live steam escape. If the trap gets stuck open, steam is wasted. If it's stuck closed, condensate builds up, causing poor heating and possible water hammer. Regular inspection, cleaning, and testing of the steam trap ensure proper operation, stable oil temperature, and safe, efficient performance of your generator's lube oil heating system. A gasket punch is used to make perfect bolt holes when fabricating gaskets. Each punch number matches a specific hole size. For example, punch number 6 for M10 bolts and number 8 for M16. Using the right punch ensures accurate alignment, a tight seal, and professional quality gasket work every time. Turbocharger washing is an important maintenance procedure that keeps your generator's engine running efficiently. Over time, soot, carbon, and oil deposits build up inside the turbocharger, reducing airflow and causing poor combustion. That's why regular turbo washing is essential. There are two main types: dry washing and wet washing. Dry washing is done while the generator is running at normal load, using abrasive materials like crushed nutshells to clean the turbine blades. Wet washing, on the other hand, uses fresh water or cleaning fluid at low load, around 50%, to remove sticky salt and oil deposits. Before washing, always open the drain cocks to remove condensate and avoid water buildup. Use only fresh or distilled water and follow the manufacturer's procedure carefully. Regular turbocharger washing helps maintain proper air pressure, reduces fuel consumption, and ensures your generator delivers reliable and efficient power every time. The fuel injector is one of the most important parts of a main engine. Its job is to atomize and inject fuel into the combustion chamber at the right pressure and timing for efficient combustion. A typical injector is made up of the injector body, nozzle, needle valve, compression spring, spindle, and high-pressure connection. Before assembling, all parts must be cleaned thoroughly using diesel oil. Inspect the nozzle and needle for wear or damage, and lightly lubricate all moving parts. During assembly, fit the nozzle, needle valve, spring, and spacers carefully inside the injector body, then tighten using the correct torque. After assembly, the injector must be tested for proper spray pattern and opening pressure using a test pump. Adjustments can be made by adding or removing shims under the spring. A properly assembled and tested fuel injector ensures clean combustion, reduced fuel consumption, and reliable main engine performance at sea. The oil-water separator removes oil from bilge water, keeping the discharge clean and marine life safe. Fuel injection plays a big role in engine performance. Bad injection causes smoke and poor power, while good injection gives smooth running and better fuel efficiency. Keep it clean for best results. Did you know that proper calibration of a generator fuel injector is very important? It ensures the right fuel pressure, spray pattern, and better fuel efficiency. When injectors are not calibrated, expect smoke, hard starting, and low power. So always make sure your injector is calibrated before engine trouble begins. The fuel injector is one of the most important parts of a main engine. Its job is to atomize and inject fuel into the combustion chamber at the right pressure and timing for efficient combustion. A typical injector is made up of the injector body, nozzle, needle valve, compression spring, spindle, and high-pressure connection. Before assembling, all parts must be cleaned thoroughly using diesel oil. Inspect the nozzle and needle for wear or damage, and lightly lubricate all moving parts. During assembly, fit the nozzle, needle valve, spring, and spacers carefully inside the injector body, then tighten using the correct torque. After assembly, the injector must be tested for proper spray pattern and opening pressure using a test pump. Adjustments can be made by adding or removing shims under the spring. A properly assembled and tested fuel injector ensures clean combustion, reduced fuel consumption, and reliable main engine performance at sea. Before replacing a generator fuel injector, make sure the engine is stopped, isolated, and cooled down. Safety first, wear proper PPE, and close the fuel supply valve. Start by removing the high-pressure fuel pipe connected to the injector. Loosen the securing nuts carefully to avoid damaging the threads. Once removed, clean the area around the injector to prevent dirt from entering the cylinder. Next, unscrew the injector retaining bolts and gently lift out the old injector using the correct tool. Inspect the nozzle tip for carbon deposits or wear. These are common signs that it needs replacement. Before fitting the new injector, check that the sealing washer and seating area are clean and smooth. Install the new injector, torque the bolts evenly, and reconnect the fuel pipe securely. Finally, open the fuel valve and bleed any trapped air from the system. Start the generator and check for fuel leaks and smooth operation. A properly replaced fuel injector ensures efficient combustion, steady engine performance, and longer generator life. OWS, or oily water separator. It keeps our oceans clean by separating oil from bilge water before discharge. Tappet clearance in a ship's diesel generator is the small gap between the valve stem and rocker arm. It ensures proper valve timing and allows for metal expansion as the engine heats up. Incorrect clearance can cause loss of power, noisy operation, or even valve damage. Regular checking and adjustment keep your marine diesel engine running smoothly and efficiently. The fuel rack, also known as the fuel control rod, is a vital component in a ship's diesel generator. Its main function is to regulate the amount of fuel injected into each cylinder, directly controlling the engine's power and speed. The rack is mechanically linked to all fuel injection pumps and is governed automatically to maintain a steady engine speed under changing load conditions. During operation, even and precise fuel delivery is essential for smooth performance and balanced combustion. If the fuel rack is misaligned or sticking, the engine may experience uneven power, vibration, black smoke, or even a dangerous overspeed. Adjustment involves checking that all pumps start and stop fuel injection at the same rack position. Technicians use gauges or dial indicators to set each pump accurately, ensuring uniform movement across all cylinders. A properly adjusted fuel rack keeps the diesel generator running efficiently, safely, and reliably, powering the ship's essential systems at sea. On board ships, a tube-type fuel oil heater is used to heat heavy fuel oil before it enters the engine. This heater operates on steam, supplied from the ship's boiler system. Inside the shell and tube heat exchanger, steam passes through the tubes, while fuel oil flows around them, allowing heat transfer through the tube walls. The purpose of this heating is to reduce fuel viscosity, ensuring smooth flow through filters, pumps, and injectors, and to achieve fine atomization for efficient combustion. Heavy fuel oil is typically heated to about 110 to 150 degrees Celsius, providing the ideal viscosity of 10 to 15 centistokes at the engine inlet. Regular maintenance is crucial, checking for steam leaks, cleaning the tube surfaces, and monitoring temperature and pressure gauges. A properly maintained tube-type fuel oil heater ensures stable engine performance, cleaner combustion, and reliable power generation at sea. The axial vibration monitor safeguards the ship's shaft line by detecting harmful thrust vibrations, ensuring smooth propulsion and reliable engine performance. The oil mist detector continuously monitors the engine crankcase for tiny oil droplets formed by overheating. It gives early warning of potential bearing or piston failures, protecting the engine from catastrophic damage. And nodes inside the sea chest protect the ship's steel surfaces from seawater corrosion. They sacrifice themselves to keep the sea chest and piping system safe and long-lasting. Inside an electric motor, electrical energy is transformed into powerful mechanical motion. At the heart of the motor lies the stator, a stationary set of coils that generates a rotating magnetic field when electricity flows through it. At the center, the rotor, mounted on a shaft, spins in response to this magnetic field, creating the motor's rotation. Between them is a small air gap, precisely maintained to ensure smooth and efficient magnetic interaction. In DC motors, commutators and brushes control the direction of current, while in AC motors, the alternating current naturally produces a rotating magnetic effect. Bearings support the shaft and minimize friction, while fans or cooling systems prevent overheating during continuous operation. Every component, from the winding insulation to the housing, is engineered to handle heat, vibration, and load. Together, these parts work in harmony, turning electrical power into the reliable mechanical drive that keeps machines and ships in motion. A lathe machine on board a ship is used in the engine workshop to repair and machine metal parts, ensuring smooth maintenance of vital machinery at sea. A viscometer measures the viscosity of fuel or oil, ensuring proper flow and efficient engine performance on board the ship. Under MARPOL Annex 6, every ship must keep the official fuel oil sample on board for at least 12 months after delivery. This ensures compliance checks and helps verify fuel quality and sulfur content. A capstan on a ship is used for handling ropes and cables, helping to heave in or let go lines during mooring operations. The emergency generator on a ship provides essential electrical power during a main power failure. It automatically starts to supply lighting, communication, and vital systems like steering and fire pumps. Located outside the main engine room, it ensures the vessel's safety and operation even in complete blackout conditions. The emergency air compressor supplies starting air to the emergency generator during a blackout. It ensures the generator can start automatically, restoring essential power for navigation, communication, and ship safety systems. When replacing the packing gland of a seawater pump, the old packing is removed, the shaft is cleaned, and new packing rings are fitted carefully to prevent leakage, ensuring efficient cooling water circulation. Gamazyme 700FN is a biological cleaner used on ships to break down organic waste in sewage and drain systems. It prevents odors, blockages, and keeps the system clean and eco-friendly. The oxygen and acetylene room on a ship is a dedicated space for storing gas cylinders used in welding and cutting operations. It is located in a well-ventilated area, away from accommodation and machinery spaces to ensure safety. Cylinders are kept upright, properly secured, and fitted with protective caps. Regular checks for leaks, proper labeling, and fire safety measures are essential to prevent accidents and maintain a safe working environment at sea. The boiler burner on a ship mixes fuel and air to produce a controlled flame that heats the boiler water into steam. This steam powers various ship systems, including heating, fuel treatment, and sometimes turbines. Efficient combustion, proper atomization, and regular maintenance of the burner ensure safe operation, fuel efficiency, and reliable steam generation at sea. The mooring winch on a ship is used to handle ropes or wires during berthing operations. It controls the tension and speed of mooring lines, keeping the vessel securely alongside the quay. Proper operation and maintenance of the winch ensures safe and efficient mooring in all sea conditions. The water mist system on a ship uses high-pressure fine droplets to suppress fires in engine and machinery spaces. It rapidly cools the area, displaces oxygen, and extinguishes flames with minimal water damage, ensuring crew and equipment safety. The preheating pump circulates hot water or thermal oil through the main engine jacket before startup, maintaining ideal temperature and preventing thermal shock to engine components. In a large two-stroke marine diesel engine, the stuffing box is fitted at the bottom of the piston rod, separating the crankcase from the scavenge airspace. It prevents oil mist and gases from escaping upward and stops scavenge air from entering the crankcase. The sealing rings and drain pockets collect and return leaked oil, maintaining pressure balance and cleanliness. Regular inspection and maintenance of the stuffing box ensure efficient sealing, reduced wear, and safe engine operation at sea. Marking and color coding of the ship's piping system help identify fluid type and flow direction, ensuring safe and efficient operation. Cleaning the fuel filters of the purifier is an important maintenance task to ensure efficient fuel treatment and purifier performance. First, the purifier is stopped and the fuel supply and return valves are closed. The filter cover is then opened carefully to remove the filter element. Using clean diesel or suitable cleaning solvent, the filter is washed to remove sludge, dirt, and carbon deposits. A soft brush may be used to clean between the pleats without damaging the mesh. After cleaning, the filter is thoroughly inspected for wear or damage and replaced if necessary. The housing is then wiped clean, the gasket checked, and the filter reassembled securely. Once all valves are opened and leaks checked, the purifier is restarted and observed for normal pressure and flow. Regular filter cleaning ensures steady purifier efficiency, reliable fuel supply, and long engine life. The safety valve on an air tank automatically releases excess pressure, preventing overpressure and ensuring safe operation of the air system. The main engine fuel pump delivers precise amounts of fuel to each cylinder at high pressure, ensuring efficient combustion and smooth engine operation. The boiler sight glass shows the water level inside the boiler, helping engineers maintain safe operating levels and prevent damage from low water. Oil mist detector testing with smoke verifies the sensor and alarm response, ensuring reliable detection of oil mist and preventing crankcase explosions. The first stage of the oily water separator, or OWS, is designed to remove most of the oil and solid contaminants from bilge water before fine separation. When bilge water enters the unit, it first passes through a strainer or filter that traps large particles and sludge. The water then flows into the coalescer or separation chamber, where gravity causes oil droplets, being lighter than water, to rise to the surface. The separated oil collects at the top and is discharged automatically to the waste oil tank through a control valve. The partially cleaned water continues to the second stage for finer separation. Regular draining of accumulated sludge, cleaning of filters, and checking of automatic discharge valves are essential to maintain system efficiency. The first stage ensures that most free oil is removed, reducing the load on the second stage and ensuring compliance with MARPOL pollution prevention standards. The second stage of the oily water separator refines the separation process, removing smaller oil droplets and impurities that pass through the first stage. After the primary gravity separation, the partially treated bilge water enters the second stage, which consists of fine coalescer filters or special absorbent media. These elements attract and merge tiny oil particles into larger droplets, allowing them to rise and separate more effectively. Clean water then flows toward the discharge line, while the collected oil is directed to the waste oil tank. An oil content monitor fitted downstream continuously checks that the oil concentration in the discharge water does not exceed 15 parts per million as required by MARPOL regulations. If the limit is exceeded, the system automatically diverts the flow back to the bilge tank. Regular maintenance of filters, sensors, and automatic valves in this stage ensures consistent performance and compliance with international pollution control standards. The main air compressor is overhauled after completing its specified running hours to maintain performance and reliability. Before starting, the compressor is isolated, power supply secured, and air lines drained. The overhaul includes dismantling key components such as cylinder heads, valves, pistons, and liners for inspection and cleaning. Valve plates and springs are checked for wear, and carbon deposits are carefully removed. Piston rings, bearings, and gaskets are examined and replaced if worn or damaged. The crankcase and intercoolers are cleaned to ensure efficient cooling and lubrication. After reassembly, all moving parts are lubricated. The compressor is rotated by hand, and a test run is conducted to verify pressure buildup, noise, and vibration levels. Finally, all safety devices, non-return valves, and pressure switches are checked for correct operation. Timely overhaul based on running hours ensures the compressor delivers reliable air supply for engine starting and control systems at sea. The lockout station in the engine room stores locks, tags, and safety devices used during maintenance to isolate equipment, preventing accidental startup and ensuring crew safety. Replacing the generator turbocharger is a major maintenance task carried out when the unit becomes inefficient or damaged beyond repair. Before starting, the generator is stopped, isolated, and allowed to cool. The air inlet, exhaust outlet, and lube oil connections are disconnected carefully to avoid contamination. The old turbocharger is then unbolted from the exhaust manifold and lifted using chain blocks or an overhead crane. All gasket surfaces are cleaned thoroughly, and the oil and air lines are flushed to remove any debris or carbon deposits. The new turbocharger is inspected for correct specifications and pre-lubricated before installation. It is then aligned properly with the exhaust manifold and air connections, ensuring all bolts and flanges are tightened to the recommended torque. After reconnection of the lube oil and cooling lines, the system is checked for leaks and free rotation of the rotor. A trial run is carried out, monitoring lube oil pressure, exhaust temperature, vibration, and turbocharger speed. Proper replacement ensures efficient air supply, stable combustion, and reliable generator performance at sea. Replacing the generator air cooler is carried out when the unit becomes fouled, leaking, or inefficient. Before starting, the generator is stopped, isolated, and the cooling water system is drained. The air inlet and outlet connections are removed, followed by loosening the securing bolts of the air cooler. Using proper lifting tools, the cooler is carefully taken out of position to avoid damage to nearby components. The seating area and connecting flanges are cleaned thoroughly, and new gaskets are fitted to ensure a tight seal. The replacement air cooler is inspected for cleanliness and pressure tested before installation. It is then positioned correctly, aligned, and bolted securely. Cooling water and air connections are reattached, and the system is refilled and vented of air. After reassembly, a test run is performed to check for leaks, proper cooling, and stable air pressure. Regular maintenance and timely replacement of the air cooler ensure efficient engine performance and reliable generator operation at sea. This is the engine room signal light column. It alerts the crew through lights and alarms for fire, flooding, and machinery faults. After long hours of watchkeeping and engine duties, nothing beats a good BBQ party on board. The crew gathers on deck, sharing laughter, stories, and good food while feeling the ocean breeze. Moments like these remind us that life at sea isn't just about work. It's about family, teamwork, and enjoying every moment together. Cheers to another safe voyage and happy crew vibes. Every wave reminds me to keep moving forward. The sea may be tough, but so am I. Out here, we don't give up. We grow stronger with every journey. Keep pushing, keep sailing. Your destination is worth it. Out here at sea, life isn't easy. The sound of the engine never stops, and sleep becomes a luxury. We wake up tired, work all day, and sometimes all night, because the ship never sleeps, and neither do we. The heat, the noise, the pressure, it's a test of endurance and strength. We're far from home, missing the laughter of family and the warmth of land. But even in the middle of the ocean, our hearts stay anchored to those we love. We are more than workers. We are seafarers, marine engineers who keep the ship alive, who make sure every voyage reaches its destination safely. We may be tired, lonely, and unseen by the world, but we stand strong because our purpose is greater than our pain. To every seafarer out there, keep moving forward no matter how rough the sea. You are not just sailing the waters, you are carrying the dreams of your family and the pride of the ocean. A main air compressor on a ship is a vital piece of machinery that produces compressed air used mainly for starting the main and auxiliary engines. Since marine diesel engines are too large to start with electric starters, high-pressure compressed air is required. Key points about main air compressor in ships. Purpose: to supply compressed air, usually 25 to 30 bar, for engine starting, automation, and control systems. Type: normally reciprocating, two-stage, water-cooled compressors are used. Storage: air is stored in air bottles, receivers, after compression. Operation: compresses atmospheric air in multiple stages. Low-pressure aero intercooler, aero high-pressure aero, aftercooler aero air bottle. Safety devices: relief valves, bursting discs, temperature sensors, and non-return valves to prevent backflow from the receiver. Maintenance: regular checks on lubrication, cooling water, filters, valve condition, and air leaks. On board a ship, one of the key responsibilities of the fourth engineer is operating and maintaining the purifier system. The purifier plays a vital role in separating impurities and water from fuel oil and lubricating oil, ensuring that only clean oil is supplied to the main engine and generators. A fourth engineer starts and monitors the purifier during operation, checking for smooth running, correct temperature, and any unusual vibrations or alarms. Regular cleaning of the purifier bowl, discs, and seals is also part of the job, as even small amounts of dirt or sludge can affect performance. When issues arise, such as leaks, overflow, or improper separation, the fourth engineer troubleshoots and carries out necessary adjustments or maintenance. They also assist during overhauls, dismantling and reassembling the purifier under the supervision of senior engineers. By keeping the fuel and lube oil clean, the fourth engineer ensures efficient engine operation, reduces wear and tear, and contributes to the overall safety and reliability of the ship. The first stage of an oil-water separator, OWS, is the gravity separation stage. Here's how it works. Purpose: to remove free oil and large oil droplets from bilge water before finer treatment stages. Process: 1. The mixture of oil and water enters the separator. 2. Due to the difference in density, oil being lighter rises to the top, while water settles below. 3. Coalescing plates or baffles are often used to slow down the flow, allowing oil droplets to join together and separate more easily. 4. The collected oil is directed to a sludge or waste oil tank, while the partially treated water moves to the second stage for finer separation and filtration. In short, the first stage is where the bulk oil removal happens by gravity and coalescence. Purpose of seal log in sewage treatment plant: to ensure no bypass or unauthorized discharge of sewage overboard, to comply with MARPOL Annex 4 and Company SMS procedures, to provide traceability in case of inspections by port state control or class. Typical sealed points in STP-1. Overboard discharge valve from STP. 2. Direct overboard bypass valve if fitted. 3. Sewage holding tank overboard valve. 4. any bypass lines that can divert sewage untreated. Only authorized personnel, usually 2E or 4E, verified by chief engineer, can break and reseal STP valves. Every seal number is unique and traceable. Any broken or missing seal must be reported immediately and entered in the log. During PSC or flag inspection, the log is checked against actual seals on the valves. In a ship's main engine, the fuel injector plays a vital role in delivering fuel into the combustion chamber at the correct pressure, timing, and spray pattern. Over time, continuous operation causes wear and carbon deposits that affect injection accuracy. That's why fuel injector calibration is essential. During calibration, the injector is tested using a calibration machine to check the opening pressure, spray pattern, and leakage. The pressure is adjusted by adding or removing shims inside the injector spring assembly until the correct opening pressure is achieved. A properly calibrated injector ensures that each cylinder receives the exact amount of fuel, resulting in efficient combustion, lower fuel consumption, and reduced smoke emissions. Regular calibration also helps prevent engine knocking, uneven firing, and damage to pistons or cylinder liners. In short, fuel injector calibration is not just maintenance, it's a key procedure to keep the main engine running smoothly, efficiently, and safely at sea.